All right, so what we've got 2 points that I've put, and it's two regions. Now, there's a kind of classic question that I've kind of done before in maths, which is if you had two ice cream parlors in an area, yeah, and you wanted to go to the closest ice cream parlor, all right, depending on where you were, which one would you choose? So basically, with construction, if I've got two ice cream parlors, if I'm anywhere in the blue region, this would be the closest one, this ice cream parlor here, yeah? If I was anywhere in this, I don't know what color, brown region, I would go to this ice cream parlor. So if you want to think in another context, if we think about city planning and stuff like that, if these were schools and you were trying to decide where I was going to build houses and where kids would have to go to school, because they do it in regions and you go to your closest school. So if I was in the blue region living anywhere, I would be put in this school. And if I was in the brown region, I'd be put in this school. Does that make sense? All right. So what happens then if I stick a third school in? All right. So what do you notice? Yeah, exactly. So this region, this pink region, has basically stolen region from the brown and the blue. Okay. Now, based on, I think if I get rid of this, so change colours. What do you notice about this line compared to the two schools? How would you describe it? Yeah, it's slap bang in the middle, isn't it? Do you know what it's called when you draw a line that goes straight through the middle of 2 points? It's called a perpendicular bisector. You ever remember constructing one of those with compasses and things like that? Remember doing that at school early on in years? Maybe not. Probably you have done it, but so this is called a perpendicular bisector because if I was to draw a line between those 2 points, this line would be perpendicular, which means at 90 degrees. And the word bisector means cut in half. All right, cut straight down the middle. So it bisects these 2 points. Now, if I put a third point in, right, how do you think that region is constructed? So we've no. So this line was the original one, and it's the bisector of those 2 points. Okay, but this new line that's come in is the bisector of those two, and then this line is the bisector of those two. Okay, and then where all three lines meet, that's our point where the lines stop. Yeah. So we're basically, all it is, it's called a Voronoi diagram. So for Emily, this word over here looks like Voronoi, as I would have pronounced it, but I was getting it wrong. It's a Voronoi diagram. It's about finding the regions that you would go to that's closest to a particular point. So anywhere in this purple is closest to that point there. All right. And it's done by finding the perpendicular bisectors of those particular points. So if I were to stick a fourth point in, okay, over here, okay, could you explain where this new purple region comes from? What have we constructed? Yeah. Yeah. And this line as well is the perpendicular bisector. So basically, as soon as I introduce a new point up here, so it's not the easiest because we're not labeling these, so it's hard for you to describe. I know that it's I've not made it the easiest, but it comes up quite quickly and nice. But basically, this point, if I add in another point, I have to bisect the points that are nearby. Why is there no bisector of this point and this one at the bottom, do you think? So why is there no line that cuts that in the middle? Well, what would be the purpose of this again? What did I say would be about deciding the regions? What are those regions? And why would you go to that dot? It's the closest. Yeah, exactly. So why would I not bother considering the bisector between this point and this one? Because yeah, it's far away, isn't it? Because if I don't go to this one, because I'm too far away from this one's not an option because these two are already closer. All right. So what we do is we only have to bisect the points that are kind of relevant in the situation. Okay. So for instance, if I were to put a point down here, okay, it's only going to affect these 2 points really, isn't it? So it's going to introduce a new region. So if I put a point down here, look, I've bisected that one and I've bisected this one to make a new region. Right? What do you predict would happen if I chucked one right in the middle? So I tell you what, I'm going to get rid of that previous one. Sorry, colours all chuck. What if I chuck a point right in the middle somewhere? What do you predict will happen? Feel free to jump in, Emily, if you like. Because everything I've done so far is just adding it on the outside. So if I do that, it gives me those two. So it's going to change the colors again. So if I chuck it right in the middle, is it going to have a bigger impact or is it going to be smaller? I just do it then. Click on it. So what have we had to do this time? Yeah. So this one, I've had to do the bisector of those 2 points. This line is the bisector of those 2 points. This line, bisect. And I've had to bisect all the points. Whereas when I did it on the outside, it's only the two. Because for this point, the only relevant ones are these two because the rest are too far away. But as soon as I put it in the middle, they all are relevant, aren't they? So I've got to find the barrier. So what you've got to do when you're constructing these Voronoi diagrams, okay, you need to consider which are the relevant points because it's all about zoning. That's what it's called, right? So we're finding the zones that are closer to one particular point than another. All right. Does that make sense? Okay, so let's have a quick look just at a different way. Same idea. I've got this autograph package now. Now I can give you a link to that. This was a free download, by the way. It's like Desmos and GeoGebra, but I actually quite like it for other things. I haven't shown you this yet, have I? I can give you a link to download it. I think it's only for PCs. It's not Mac, so it might not be useful for you. But what's quite useful about it is I can create these Voronoi diagrams quite easily. So for instance, if here is a point, right? So that's a school, and this is a region. Why are there no lines yet? Yeah, there's only one point. There's only one region. There's nothing to consider. You know, where would I go to school if this was where I lived? I'd go to school there, right? But what if I introduce a second school? Okay, suddenly I've got my whole region, but now I need to plan where would people have to go. So like I said, the other program did it automatically, but now what we can do is we've got these 2 points, and I've got to, what did I say we had to construct? Yeah, the perpendicular line. So if I do a line perpendicular bisector, there you go. All right, so that's like the 2 regions that we've got before. All right, make sense at the moment, basic level? Cool. Right, I'm going to introduce a 3rd point up here then. Now, unfortunately, with this software, it doesn't automatically put my regions in. So I have to figure out where my lines need to go. So what do we need to do to now figure out how many regions should there be? Should be 3 regions, yeah. 1 region round each point. So how can I do it? I don't know whether I can I give it a label maybe? Show label. Okay, that gives you something to talk about. All right, so any idea, while I'm doing this, any ideas how I could figure out what the 3 regions would be using points A, B, and C? Yeah, good. So we've got A and B sorted. Now we've got another. So C has to consider A and B. So let's do a perpendicular bisector between A and C. All right. So nice and easy using a computer. Now, is that all we've got to consider so far? So I've got A and B split with the red line. I've got A and C split with this yucky line. All right. Do I need to do anything else? So what have I got to do to create the other region? So I've split A and B with the red line. I've split A and C with this line. What's still left to do? Split B and C. So let's split B and C. All right. Bisector. Okay. So this is still a bit kind of, it's not so clear. So what I'm going to do is, so that we're clear, I'm going to take a screen clipping of this. All right. Numbers don't really matter. Put it on another page. Okay. All right, so this is the diagram. So let's figure out where our regions need to be. All right, so I've got the lines, but I need to figure out the regions. So splitting A and C is this line here, yeah? So that part of the line definitely splits. Now, where do I stop? At the middle, okay? So this is where we stop. Now, the red line splits A and B, so I'm going to go split like, oh, sorry. I did stop much sooner than that. My computer's obviously going slow. Let's see. Right. So I'm going to, again, like you said, I'm going to stop in the middle. All right. Now, how do I figure out? So I've now got one region here. And that's the region that A goes into, yeah? So now how do I figure out the B and C regions? Exactly. So I'm going to go from the center. I'm going to go across out there, yeah? So obviously this bit here. So that's my B region. And then I've now also got my C region is all of that. So it'd be quite easy, especially if you were doing this pen and paper. All right, I could now get rid of kind of the extended lines. Oh, my computer's going slow. All right. So that would be my three regions. So it's all just about perpendicular bisectors. All right. So what would happen then, all right, if I were to throw in another point? Okay. So let's say I do this pen and paper wise. Let's throw in a point up here. Let's call that D, point D. What would you have to bisect? Which points? Yeah, so I'd have to... And then which one? B and D. So I'd have to do B and D as well. Okay. Now, would that line carry on or would it stop at this point? I think it would stop there. So then that would give me a region, okay, that would change a bit, okay? So I'm only, so you know, so like we were talking about, I only need to consider the points closer to D. So C, I need to bisect. B, I need to bisect. A, I don't need to worry about. Okay, so let's have a look on the other screen. So let's just say, let's put that point D in. All right, put it here. Point D. All right, so like you were saying, we've got to do the bisector of that one, and then we've got to do the bisector of those. So it's starting to get a bit messy, isn't it? But you know the idea. So you would have to, C region now would be cut by this, okay? Can you see it? Because I know it's starting to get a bit messy, but I think I can, maybe I can highlight on here. So this region here would be kind of like from that point that we were in and up there, okay? A's region doesn't get affected, okay? This line that goes all the way through doesn't go all the way, does it? So B's region would, well, how far would B's region go? So it was the green line before, but now it has to stop at the blue line because it can't go closer to D. All right, so B's region has been affected. All right, and then we've got D's region as well. Okay, so it starts getting kind of more and more complicated the more points that you've got. But Do you get the general gist of what we're doing? Yeah. Okay. So let's just. Sorry, I'm going to just check using this other one. So let's do. Let's put it where we kind of had it. So we had a point here, point up here, we had a point down there, I believe, and then did we chuck one up here? So that's what it would look like. And that was what we were kind of saying, yeah? A, B, C, and D. So that confirms what we were saying. All right, so that's the general gist of what a Voronoi diagram is. It's about finding a region. Now, what skills have you got already that you are going to need to apply, do you think? Yeah, definitely, I'd say. Right, so let's focus on that. First of all, let's think about the lines. What kind of lines have we got? They are all just straight lines, yeah? All right, what do we in general know about a straight line? What form does its function take? So we've got y equals remember it for straight lines? mx plus c, or is it y equals ax plus b? Up to you, whichever one you want to use. Okay. So what we've had before is if I give you 2 points and ask you to find the equation of the line, sorry, between those 2 points, how would you do it? So let's say this was 0.35 and this was 0.69. How would you find the equation of the line between those 2 points that joins them? You don't have to tell me the answer, just what's the steps that you would do. So for instance, yeah, what does that give you? And what does it go on? Yeah, and what's that called when you do that? That's the gradient now. Gradient or the slope. And how does that relate to the equation? Yeah, the m or the n. Yeah. So that's your gradient. So that tells you that particular part of the function. All right. And then you can use that and use these numbers to figure out what the b is, because b is often it is the where it intercepts the y-axis. Yeah, so if I were to continue this line on, whatever that would be the plus b or the c. Yeah, but this line doesn't actually get there, so you should be able, and we can review this, to figure out using 2 coordinates. You should be able to figure out the equation. All right. Now, why is that helpful? Well, it's helpful because if I want to find the perpendicular bisector, the line that cuts them in between, all right, that is also a y equals mx plus c line, or ax plus b. But what do you remember what it is about the gradient of a perpendicular line? Yeah. So if this one's L1 and this one's L2, line 1 and line 2, if M, so the gradient for line 1 is, let's say, 2, then M for line 2 being the perpendicular line, any perpendicular line would be, do you remember? Not quite. It's -1 divided by whatever it was, so it's half, yeah, but close, right? So that's how we figure out the gradient of a perpendicular line. But we want to know that extra little thing, which is it's a perpendicular bisector, so it has to go through what point? This would be the midpoint. So you've been asked to find M before, which is the midpoint of 2 points. How would you find the middle of these 2 points? So to start with, I know that my x coordinate is halfway between 3 and 6. So what's halfway between 3 and 6? Well, the difference between 3 and 6 is 3. So if I divide that by 2, I get 1.5. So I'm 1.5 added on to 3. Okay, so that will therefore be 4.5. And then I do the same thing for the y direction. So I was at 5 at this point. I go up to 9. So what's halfway between 5 and 9? 7. Okay, so the coordinates of the midpoint are 4.57 in this case. So now I know that the gradient of this the equation of this perpendicular line, right? I know that the gradient is -1/2, and I know that I have a single point which is 4.57. So if I'm looking for that equation, mx plus c, I can start with y equals -1/2 x plus c. How do I then find the c? We've done a lot of that this term with straight lines, with quadratics, with exponentials. What do I do? And yeah, because we've got x is 4.5 and we've got y is equal to 7. So we've got 7 is equal to -1/2 multiplied by 4.5 plus something, plus the c. All right, so what's half of 4.5? Well, that would be 2.25, but it's negative. So what do we have to add on to -2.25 to get to 7? Well, that's quite simple, because you just have to add on 7.25. No, sorry, 9.25, don't you? To get from -2.25 to +7, you have to add on 9.25. Does that make sense? Okay, so then we can use this information and say that if I've got these 2 points, my A and my B point, and I know that they are at those 2 coordinates, which are 3, 5 and 6, 9, okay, that the equation of the line that cuts them in half is y equals -1/2 x plus 9.25 from that information I've got. Yeah. So why is that useful? Well, that's useful because this line would cut those 2 points in half. So what kind of diagram have I just created? Well, it's the one we were talking about. So what is it? Well, so this diagram that I've just drawn, I've got now 2 points with a line that cuts them in the middle. So I have now created a diagram where I've got 2 points and a line cutting them, and therefore I've got 2 regions. So what is this diagram? What would I call it? I would call it this would now be a Voronoi diagram. Yeah. So what you're going to be asked to do in this little section, this is a brand new topic for the new course, by the way. It's not completely new in terms of skills because you've had to do the straight line stuff before, but we've never had to apply them to these Voronoi diagrams before. So what you're going to be expected to be able to do is apply this work on midpoints and gradients of straight lines and things like that. All right. So given that kind of brief overall introduction, there's not an awful lot more to it, to be honest. What maybe you should think about doing now, well, going forwards, and we'll continue it next week. Obviously, in your textbook, you've got this chapter. So this is what it's then showing you. This is what we've kind of just talked about. So a Voronoi diagram is all about just finding those regions, okay, by doing the perpendicular bisector. And then it will ask you, for instance, in this exercise, you know, by finding the perpendicular bisector that goes between each of the points, create your diagram, yeah? And then we can solve problems like they've got a toxic waste dump problem, all right? Where do you put the toxic waste dump? Now that's a different version to where do people go to school, but same idea, yeah? How does that sound as a start, ladies? Yeah, that's basically it. So that sums up the whole thing, but there's other things. So you can see here, probably in this example, they're asking you for lengths of lines using Pythagoras' theorem. So this topic is really a summative of all the stuff to do with straight lines that we've done in previous topic. All right, so it's quite a nice finishing point. All right, so we'll get this stuff done over the next few days, next week, Monday, Tuesday, Wednesday, and then we can move on to stats next year. How does that sound? All right? Yeah. So I do believe we've got another live lesson on Monday, right? You're back in it on Monday? Yeah. No more classes. You have normal classes, yeah. Yeah. So Monday, Tuesday, Wednesday, I believe you've got normal classes. So I think we've got a live lesson. I can't remember, is it Monday or Tuesday? No, we have it Tuesday, don't we? So Monday's lesson, I guess that gives you a chance to read through this section, see how what I've just said makes sense, and then Tuesday we can go through any of the problems that we can do. All right, brilliant. Okay.